Let's take a look at using Fathom to see if my student Brittany has ESP. Just a few minutes ago, I randomly picked a card, and on the card there was either a plus, a wave, a circle, or a star. I randomly picked a card and I looked at it, and then I got Brittany to try to read my mind and predict what's on the card, and she actually got 9 correct out of 10 guesses. So, do we think she has ESP, or is she a really lucky guesser? I mean, is this likely to happen by chance alone? So, I thought first of all, before we calculated the theoretical probability using our calculators, that we would take a look at a simulation. And if you take a look here, we can see we've got the 4 different types of cards that I would randomly pick, and the 4 different cards that Brittany might pick. And the way this is being done with Fathom is we're doing a random pick. The formula is random pick, and here we can see we've got the 4 different outcomes: wave, star, circle, plus. And that's the same thing here for the formula for student pick, and that is star, circle, wave, or plus. So each of these has an equally likely chance of being chosen at random. And then what we have over here is a column called match. Let's take a look at what the formula is for match. Here it's going to display false if there is not a match. Notice plus and wave is not a match, and true if there is a match. So plus and plus is going to display true. So is the teacher pick equal to the student pick? Did they choose the same card? If the answer is yes, then we have a true here, and if it's no, then we have a false. So let's take a look at this. If you take a look here, you can see we've done 10 trials here, just like Brittany got 10 attempts and she got 9 correct. Here we can see that there were 4 correct and 6 incorrect. So it's possible you might get 4 correct and 6 incorrect. Let's do Control Y to re-randomize. Notice, I'm going to try to convince you here that the chart is changing. You can see how things are changing in the chart. Here we have 4 correct matches, and then 2 correct matches, and then 3 correct matches, and then 2, and then 1. Oh, here we got 6, but I don't know. If we keep doing this, are we going to get 9? Oh, this one they got them all wrong. There was no true statements. They were all wrong. Here we've got 4 that were matches, so it seems very unlikely that you're going to get 9 out of 10 correct just by guessing alone. Okay, this is our simulation. All right, well, let's take a look over here at a more theoretical model using Fathom. We have a binomial situation here because we have success or failure. We have 2 different outcomes. She either guesses correct or she guesses incorrect. So there's either a match or there's not a match between what I picked and what she picks for what's on the card. The probability is fixed at 25% each time, and I'm going to randomly pick a card, so the probability of me picking an individual card is 25%, and if she were just to guess, the probability would be 25% each time. So the probability is fixed at probability of success is fixed at 25%. Probability of failure, not getting a match, is 75%, 3 out of 4, 75%. And the number of trials is fixed at 10 trials, and we're looking for the number of successes, in this case 9 successes out of the 10 trials. And we are going to assume that there's independence here, that Brittany is not somehow using her previous answer to figure out the next answer, that her guess from time to time, from trial to trial in those 10 trials is independent. So let's take a look here at what formula we have here. Here we have the random binomial formula, and we have 10 trials, and the probability of success is 0.25. So let's take a look at what this is doing. I'm going to hit Control Y to re-randomize, and you can see that my dot plot over here to the right is changing. Well, what is this showing here? Well, this is showing the number of matches, or the number of correct, that we would see in 10 trials. Notice the most common number of correct is 3 in this particular set of 100 trials. Here the most common correct was 2. But the question we really want to ask ourselves is, how likely is it that we're going to get 9 correct out of 10. I see a 6, see a 7. That time we only had 5, now 6 is the most. But I don't think we're going to ever see beyond 7. I mean, it could happen. But it looks like it's very, very unlikely. I'm starting to really think now that Brittany actually has ESP, because this is really kind of strange. We're not getting any 9s, whether we did the simulation this way or we did the theoretical probability with the binomial distribution. We're not getting 9 out of 10 correct. So what is the actual probability? Well, what is the actual probability of getting 9 out of 10 correct by guessing? Our probability of success is 0.25. The number of trials is fixed at 10. And our question is, what's the probability of getting exactly 9 correct out of 10? And we're going to use the formula here where we have the number of ways to arrange our successes among the 10 trials. So that's 10 choose 9 times the probability of success, and there were 9 successes, so 0.25 success and success and success and success, doing that 9 times itself, times the probability of 1 failure. So let's take a look at our calculator for this. If I can get to the calculator. Let's take a look at our calculator for this. We would do 10 math probability combinations 9. So this is the ways to arrange those 9 correct guesses among the 10 guesses. And then we'll multiply that times the probability of success to the 9th power, since there were 9 successes, times the probability of failure, and there was just one of those, so we don't even have to put the exponent there. So the probability of getting 9 out of 10 correct by randomly guessing is 2.86 times 10 to the negative 5th power. Very, very, very unlikely. Another way we could use our calculator to figure this out is under the distribution menu. If we take a look down here towards the bottom, we have 2 options for binomial. One is a binomial probability distribution function, and one is a binomial cumulative probability distribution function. This would add up the probabilities from 0 up to a certain number of successes. But here we want to know the probability of getting exactly 9 matches out of 10 trials. So we have 10 trials. The probability of success is 0.25, and the number of successes is 9. All right, let's see if we get the same result, and we do. So does Brittany have ESP? Well, either she has ESP or she and I planned ahead of time some signals so that she could actually get 9 out of 10 correct. I hope you guys enjoyed this screencast, a little bit about binomial probability and using Fathom.